Hello and welcome back. In this video we're going to look at list slicing, which allows us to go in and grab a sublist from a list. And we'll also look at some of the other functions and methods that are available for working with lists. So, last time we looked at indexing into lists, which allows us to reach in and grab one particular item from a list. List slicers let us go in and grab a series of items from a list. And this is done by extending our syntax for indexing. Instead of just providing a single index value, we're going to provide possibly two values separated by a colon. And we'll see some variants of that. If we miss the first of the values, the value before the colon, then it's going to default to the first subscript, index 0. And if we miss the second subscript, it's going to default to the length of the list, len list. And this is called slicing. Okay, so let's run our little program that we used last time, which includes, if you remember, the fact that we've got the list of squares sitting there. So it's a list of int values. That's where it was defined. So there are 8 elements in this list. We could check that with len of squares. Okay, so we can go in and grab a sub list from this list by using our slicing syntax. So it's the square brackets to say we're going to grab a series of elements from this list. If we want 2 to 4, this will grab elements 2 and 3, index 2 and 3. So it grabs from the first index up to but not including the second index. Okay, so 2 to 4 is going to give us 0, 1, 2. It's going to give us this value, and it'll give us index 3. So this is index 2, this is index 3. It won't give us index 4. It gives us from the first index up to but not including the second index. So let's try that and make sure we get what we expect. Yes, we get a list that contains 4 and 9. If we miss the first index, this defaults to 0. So this is going to give us all elements from element 0 up to but not including index number 4. So that'll be 0, 1, 2, 3, but not 4. So we should get a list containing 0, 1, 4, and 9. Let's check that. There we go. Exactly what we expected. And if we do it the other way and we provide the first index but not the latter one, what we'll do in this case is we'll get everything from index 3 up to and including the final element in the list. So index 0, 1, 2, 3, 9 should be the first, and we should get a list containing all of those highlighted values there. And that's what we get. Okay, so this is a really powerful method for slicing up any sequence of data. We're applying it to lists here, but it's actually available for other sequences as well, including strings, so you can apply this technique to strings. We can also assign to list slicers. So for any list, we can take a subset of that list and replace it with a different sublist. So the syntax for doing so is mylist index from some start location to some end location, assign into that those series of values another list. So what that'll do is replace the elements starting at the start index up to but not including the end index. And it'll replace those elements with whatever is the contents of the other list. So for example, if we have mylist is a list of the low odd values 1, 3, 5, 7, 9, and 11, and we can look at the content of that just to check mylist. There we go. We can assign into a subset of that list, mylist 2 to 4 equals, and some negative values, -3, whoops, a list that is -3, -9, -11, and -13. Okay, that's what the example shows. So what we're going to do here is starting at index 0, so that's index 0, starting at index 2, that's index 0, that's index 1, that's index 2, up to but not including index 4, so that's index 4, 0, 1, 2, 3, 4. So it's going to take index 2 and 3, that's them highlighted, and replace them with the content of this list here. So let's do that and check the answer. My list is now 1 and 3, which we expected. Then 5 and 7 have been replaced with these series of values, so -3, -9, -11, and -13. And then 9 and 11, the other ones we said not to touch, they've remained unaltered. Okay, so that worked as we expected. We're able to reach into our list, select a series of values to be replaced with another series of values in a list. We can also do insertion using a technique similar to this, but it's a little bit confusing, and probably the insert method that you'll see soon is preferable. So if my list is a list, let's just reassign to it and make it 1, 3, and 5 for a simple example, and say my list from index 1 up to but not including 1, which is a little bit odd, but it's legal, equals -3 and -9. What we'll see here is that we're going to start at index 1, insert this series of values, but we're not actually going to replace index 1 in this case. So it's starting at 1 up to but not including 1. So the result of this is the list that contains 1, then at index 1 we get -3 and -9, and then 3 and 5 have been maintained, so up to but not including the end index. So it's a little bit confusing. Probably the insert method is a nicer way to insert into lists, but that's also available via slicing. Okay. So we have a large number of list operators that are available to us too. So list 1 plus list 2 is just the concatenation of two lists. All of the elements from list 1 followed by all of the elements of list 2. So as the example there shows, and we'll do it down here, the list of 1, 2, and 3 in a simple expression at the shell plus 7 and 8 gives us a single list that is 1, 2, 3, 7, and 8. And then if we have some small list like 2 and 3 and 4, or 3 and 5, whatever values, actually let's do them in a different order, 5 and 1, and we multiply that by 5, what you might expect, having seen what multiplication does with strings, is that it just gives us 5 repetitions of the list 5, 1, or the elements there. So we see 5, 1, 5, 1, 5, 1, 5, 1, 5, 1. So it's 5, 1, 5 times contained within a list. And we could do that with any type of list, whether it's a list of strings, a list of floats, a list of lists, as we'll see later. We can use the in operator as well to determine if a particular value is contained in a list. So let's have a look once more at what my list contains. There we go. And we can say, is 7 in my list? And the answer to that will be the Boolean value false, because it isn't. Is -3 in my list? The value for that will be true, because -3 is contained in that list. We've seen the len function available for list already, so this just tells us how many items are in a list. So if we look at my list again, my list contains those items. How many items are there? There are 5. We could use the len function to determine what the length is of any particular list. So it tells us. Nice shortcuts also, though, as we've got a function called sum that will sum up the values in any numeric list. So sum of my list will do the addition of the sum total of 1, -3, -9, 3, and 5. The total of that is -3. You can't use the sum function to concatenate strings, but you can use string.join, which is a method we haven't looked at yet, but you might want to look it up. We can also use the function min on a list, so we can say what's the minimum value contained in that list, which should be -9, and it is, and we can use the function max to say what's the maximum value in our list, which is 5, and it is, gets it correct. Okay. Finally, we have a lot of list methods available to us. And most of these methods are methods that are going to return the value none which means no object returned essentially. So these are mutator methods, meaning they take a list object referred to on the computer's memory and they alter the content of that list. Rather than returning a new and different list, what they're doing is taking the original list and mutating it in some way, changing the series of values contained in it. Okay, so let's have a look at mylist. Again, mylist as it currently stands. There's mylist. A function you don't need to know about this, but it's probably worthwhile showing it to you right now. We can say what's the ID of mylist. This is a built-in function available in Python. And what the ID is actually the address that this object has on the computer's memory. So the address of mylist, the reference that's the location in the computer's memory where mylist is stored, is actually 442.1944520. Okay, doesn't particularly mean anything to me or anyone else, but that's just the location on the computer's memory where this list is stored. So we've seen the content of mylist. That's what the content is. We can do an operation, invoke a method on this list. So mylist.sort, for example, the last one on this slide, mylist.sort passing in no arguments. And what's happened here, nothing has been returned, so nothing has been printed out by the shell. The value none has been implicitly returned. Okay, so there's no explicit return value. Any function that doesn't explicitly return a value implicitly returns none. But you might be saying, has it done anything? Well, absolutely, it has done something. We can look at the content of mylist now, and we'll see that it is sorted in numerical order. The smallest value is now first, and the largest value is now last. We can look at the ID of mylist. I said that this was going to be a mutator, which means it's taken the object at that location in memory and altered it without moving it anywhere else in memory. It's still at the same location. It's the same object that's been changed in some way. So if we look at the ID of mylist, we see it's exactly the same as it was before, and that's saying it's still stored at exactly the same location in memory. So mylist has been mutated now by sort. We can still use it exactly the same way as we would have done before. I can do mylist.append and add a value or a series of values into this list. So I might append the value, let's say 555 to my list. Okay. Again, none has been returned. It's not explicitly returning a value. It's implicitly returning the value none. But it has mutated the object, so we can look at the object and now 555 sits on the end of that list. And again, the ID of mylist is unaltered, so it still resides at exactly the same location in the computer's memory. I'm not going to show you all of these. You can experiment with these in your own time, but mylist.index, so that's this one here. I'm asking it, what's the index of the first occurrence of some particular value? So what's the index of the first occurrence of 3? It should say index 0, index 1, index 2, index 3. It should say 3, so let's see if it does. Yep, it's telling me that 3 is at index 3. And what's the index of 5? It should be 4. It's at the next location. Okay. And index returns an error if the value is not found. What other ones could we do? We could do, let's just do one more and reverse the list. So mylist.reverse, passing in no arguments. It's just going to reverse the set of values in that list. These are tremendous shortcuts when your lists contain, say, a large set of data that you want to sort into alphabetical order. You've got built-in functions that will do that for you. So we can now look at the contents of mylist, and the order is the reverse of what it was a minute ago. So it's now going from the maximum value to the minimum value. And yet again, to prove that it's mutated the object rather than returned a new object, a new and different object, we can look at the ID of mylist, and it's still stored at exactly the same computer address in memory. Okay, next time we're going to talk about a trap that's very important in our understanding of computer memory, and it explains why we've been so careful to talk about references so far in the videos. Okay, do experiment with some of those methods that we've just described and with the functions and slicing that we've been talking about today. Thanks.